So what does it mean to do a matrix product? So the entries in product, so I should say, sorry, in the matrix product are obtained by doing the dot product. So let's say we're doing the product AX. So we do a dot product between the rows, dot products, between the rows of A and the columns of X. So maybe I should say here, A is a 3 by 3 matrix. Okay, that just means there's 3 rows and 3 columns. And X is a column vector, which we can think of as a 3 by 1 matrix. It has 3 rows and only 1 column. Okay, so now what can we do? Well, I said we're going to do the dot product between a row of A, 2, 3, 3, and a column of X, X1, X2, X3. Well, that dot product will be 2 times X1 plus 3 times X2 plus 3 times X3. Okay, it's exactly what we want to set U1 equal to. Let's do the second one. I take the second row of A, 2, 4, 5, and I do the dot product with X1, X2, X3. I will get 2 times X1 plus 4 times X2 plus 5 times X3, okay, which is this thing. And same with the third one, 1 times X1 plus 1 times X2 plus 2 times X3. Okay, so that's matrix multiplication. So again, let me maybe restate that more generally. So if I want to find the entries of a product of 2 matrices, A and B, so I'm saying matrices, but they could be, of course, vectors are now a special case of matrices, just by taking a matrix of width 1. Okay, so if I have my matrix A, and I have my matrix B, and then I will get the product AB. Well, let's say, for example, that A, this works in any sizes. So let's say that A is a 3 by 4 matrix. So it has 3 rows, 4 columns. And here I'm not going to give you the values because I'm not going to compute everything. It would take, the rest of the lecture. So, and let's say that B is maybe size 4 by 2. So it has 2 columns and 4 rows. And let's say, for example, that we have the second column is 0, 3, 0, 2. So A times B, I claim, will have, well, the entries should be the dot products between these rows and these columns. Here we have 2 columns, here we have 3 rows, so we should get, 3 times 2 different possibilities. And so the answer will have size 3 by 2. Okay? And, well, we cannot compute most of them because I didn't give you numbers, but one of them we can compute. We can compute the one that goes here, namely this one, in the second column. So I select the second column of B, and in the first row, so I take the first row of A, and I find, well, 1 times 0, 0, 2 times 3, 6, plus 0 plus 8 should make 14. So this entry here is 14. Okay? So, in fact, let me tell you about another way to set it up so that you remember more easily how, what goes where. So one way that you can set it up is you can put A here, you can put B up here, and then you will get the answer here. And if you want to find what goes in a given slot here, then you just look to its left, and you look above it, and you do the dot product between these guys. Okay? So that's, I think, an easy way to remember, First of all, it tells you what the size of the answer will be. The size will be, well, what fits nicely in this box should have the same width as B and the same height as A. And second, it tells you which dot product to compute for each position. Okay, so you just look at what's to the left and what's above the given position. Now, there's a catch. Can we multiply anything by anything? Well, no. Okay, I mean, I wouldn't ask the question otherwise, but, but anyway, see, to be able to do this dot product, we need to have the same number of entries here and here. Otherwise, we can't say take this times that plus this times that and so on if we run out of space on one of them before the other. So the condition, and it's kind of important, so let me write it in red, is that the width of A must equal the height of B. Okay, sorry, it's a bit cluttered, but hopefully you can still see what I'm writing. So, okay.